everyone. So I'm going to be speaking about some impacts to restored reefs from the recent cyclone season, from Cyclone Jasper that happened in December 2023. But before I start, I'd like to acknowledge the traditional owners of the sea country on which this work took place. So that's the Kuku Yulanji, the Gunganji and the Irukandji people. I'd like to pay my respect to elders past and present and also acknowledge that sovereignty was never ceded. So you've probably heard about quite a few intervention methods over the last few days. The one I'm going to be talking about today is the Mars-assisted reef restoration system. So it does use a structure that you can see here called a reef star, but the system as a whole involves a comprehensive process of training, site selection, preparation, installation, and also ongoing monitoring and maintenance. So if this is all undertaken correctly, it's designed to not only stabilise rubble, but also undertake a number of other ecosystem services, provide a number of other ecosystem services, including increased accelerated carbonate production, coastal protection, and also provision of new substrate for both attached and natural recruitment of corals. So the science and practice of reef restoration has come a long way since the days of dumping refuse into the ocean to be used as artificial reefs or fish aggregating devices. But unfortunately, we're still seeing some ongoing impacts as a result of some of the past efforts. One of these is issues with instability, structural instability. And these news articles are all from the past year, 2023, 2024. Unfortunately, these all refer to efforts that occurred in decades past that were all done with great intentions, but they're still having these instability issues and getting washed up on beaches all around the world. So this issue, it's acknowledged both in the scientific community and the broader community, and it does affect the social licence that we have for reef restoration in a lot of areas. And as restoration practitioners, it is one of the biggest questions we get asked. A lot of people, when they hear about a project being planned, one of the questions they ask is, how do we know it's not just going to end up washed up on the beach in the next cyclone or the next big storm event? So these concerns, they're not to be dismissed. The power of wave action can be really huge, as you can see from some of the enormous Porites bombings that were washed up on beaches at Hook Island in the Whitsundays after Cyclone Debbie. So what are some of the characteristics of restoration that might affect or potentially impact their ability to withstand these huge wave events, these huge cyclones? So other than characteristics of the disturbance event itself, we might want to look at the actual size of the restoration, the footprint. We might also want to look at the depth that it's installed at, and also potentially even the age of the installation, how long it's been given to establish itself. So Cyclone Jasper, it tracked up the Great Barrier Reef over December 11th and 12th in 2023, and then it turned west and crossed the Great Barrier Reef somewhere near Cooktown, or just south of Cooktown, on the evening of December 13th. So reefs in this region, they did suffer a lot of impacts, not only from the physical disturbance, but also, as everyone in here I'm sure knows, from the freshwater inundation associated with the flooding events that happened in the days afterwards. But these impacts, they were really patchy, and that's often the case with cyclone events. And it does mean that these impacts, because they were severe in some places and almost non-existent in other places, it is really hard to extrapolate impacts that you might see on one reef and sort of extrapolate that to a reef system up as a whole. So if we zoom in on that stretch on the map from the previous slide, if we zoom in on that stretch between Cooktown and Cairns, which suffered from the longest period of high wave action, the yellow and orange zone there, we do actually have 5 Mars sites within that region, so we do have 5 sites that we can actually extrapolate some information from. And so the results here are going to be just a little bit of a run through each of those sites using a range of different data. Each of those sites are slightly different ages, different sizes, so there's a few different things we can look at and see if we can find some trends. So just a quick overview of some of the data we collected. At a couple of the sites, we did actually have some monitoring data that we collected pre and post-cyclone, so that's photoquadrats. And then at some of the other sites, well, at every site, we had divers doing both a visual assessment and a tactile assessment to test the stability of the site. And then we also had some observations from skippers that were out on the reef in the days leading up to the cyclone to get an idea of actually how strong those waves were, how high those waves were in the days leading up, and how long they occurred for. So the first site I'll show you, it's from Opal Reef. It's in Opal Reef, and that's the site that's actually closest to where the cyclone ended up crossing the reef. Just the chart here is to show you that there was up to 16 hours of cyclonic winds in that region. It's from Agincourt Reef weather station, so just to show you that there were quite strong winds in that region during a period of time. Now this particular site, it's really small as reef SAR installations go. It's only 10 reef SARs. And the actual purpose of this site was, instead of a restoration site, it was an experiment for coral attachment. So it does mean that by the time the cyclone came through, there were actually very few fragments left on that site. So it's not exactly a normal reef SAR site. However, it was still installed with all the usual stability measures, the anchoring and everything that we normally do. So what ended up happening at Opal Reef? There were some quite severe impacts to the reef area around at Opal Reef. Quite a few corals were upturned, lots of different growth forms, table corals and massive corals, and quite a lot of breakage of branching corals as well. There was also some minor movement and damage to some coral nursery structures that were out there on site. Just a side note to note, they're not rubble stabilisation devices, but just so you're aware that there was quite severe, obviously, wave action to that particular site. Now, if we look at the actual reef SARs, you've got the before and the after. There was little to no evidence of any impact from the cyclone itself. No impact to stability. Unfortunately, because there's no fragments on that, or very few fragments on those reef SARs, we can't actually say whether there was any breakage of fragments or not. So the next site I'm going to show you is at Hastings Reef. So it is a little bit further south from where that cyclone crossed the coast. However, it is on the Outer Great Barrier Reef, so it's alongside where the cyclone sort of tracked north for that period of days. Now this site is a fairly young build. It's only 6 months old, and it's 100 reef SARs installed in around 7 metres of depth of water. So diver observations indicated that in the reef area around there was quite widespread dislodgement of large corals and coral rocks as well, and hundreds of smaller fragments were spread out all over the reef. So quite a bit of impact to this site, to this reef. Now on the reef SARs, there was a small number of fragments dislodged, but what we actually found there was that many of the natural corals that were dislodged, they actually entered the reef SAR build itself and sort of became lodged into that reef SAR matrix, into the structure. And they started to accumulate in there along with some pieces of rubble and almost became stuck in there. Once they got in there, they sort of couldn't come out. So that was a really interesting observation that we noted. There was one location on this build, and you can see it in the photo there with the orange circle, that it's about 1 metre across, where there was some rubble that was gouged out from the side of one of the reef SARs, but this actually didn't have any impact to the stability of the reef SAR or to the structure as a whole. So that was a fairly deep site, about 7 metres. There's also a reef SAR site also at Hastings Reef, just a few hundred metres away, which is quite a bit shallower. It's in only about 1 or 2 metres of water. It's also 100 reef SARs, and it's about the same age as the previous one. So the natural reef here saw very similar impacts, similar number of corals that were dislodged and quite a few fragments all around the reef. And also the reef SAR site did see similar results as well. We did see quite a lot of corals lodged inside that reef SAR matrix and starting to sort of become stuck in there, and a little bit of accumulation of rubble, which was effectively almost raising the level of the rubble within that matrix of reef SARs. No impact to the stability of this structure as well. other than that accumulation. So what happens when you look at a little bit more of an established site? So this site is at Green Island. It was installed in November 2020, so it's about 3 years old by the time the cyclone came through. 3 years old. It's 165 reef stars and it's sitting in about 3 or 4 metres of water. So at Green Island there was some dislodgement of corals. We did have some data collected at this site. We had the pre and post monitoring. No significant change to any substrate cover was seen at the control site, so on the natural reef. Over onto the reef star site, there was again some dislodgement of corals, a few fragments broken here and there, and also a little bit of accumulation of that rubble inside the structure, mainly on the deeper edge. But the data didn't indicate any impact at all to either the control sites or the reef star site. So there was a little bit of damage seen at this site, but it seems like being an inshore reef, potentially, the data didn't indicate any significant changes to either the natural reef or the reef star site. So that site overall went pretty well through the cyclone. So that was a smallish site. How about if we look at a little bit more of a larger site of reef stars? So this one here at Moore Reef that I'm going to go into, it's 439 reef stars that were installed over a period starting from June 2020. So it's quite large and it's quite established. The natural reef here did see some fairly widespread dislodgement of corals. It also saw some large areas of soft corals that actually got ripped out from the substrate. And what we saw with those is it seemed as if the soft corals were being ripped out and exposing the rubble, but not only that, it appeared as if the rubble itself was also being thrown around, because you ended up with these kind of concave gouges where soft coral used to be. So yeah, quite a bit of damage to the natural area there. On the restoration site, there was some dislodgement of fragments, but what we saw was actually similar to what we saw at Hastings Reef. So those fragments appeared to mainly settle within, underneath and within, and also alongside the reef star matrix. And actually, by the time we got out there, it was about a month or 5 or 6 weeks after the cyclone, we'd actually noticed that some of these fragments had really started to settle in their new place and even started to overgrow their new home. So in a way, we were almost noticing a sort of a spreading of the footprint of the site as the corals settled on the outside of that restoration footprint. Interestingly, there was also an area of soft coral that is surrounded by reef stars that didn't appear to be affected by the cyclone. So I'm not sure what happened there. Potentially, the reef stars protected it from a little bit of the harsher waves. So we do also have some data from this site as well. What we found in the data was that there was no evidence of any negative impact on coral cover across any of the sites. So that's the restoration site and also the control sites. But we do know anecdotally that there was up to 30–35% loss in coral cover at some spots on Moore Reef. So it's not to say that there was no damage whatsoever on Moore Reef, but it really does point to that patchiness of impacts that you do see in cyclone events. Having said that, there was some variability in the way that sites responded to this disturbance event. What we saw was that in the degraded control site, that's the empty rubble bed that was never restored, there was some shifting of abiotic categories from the between the pre and post-cyclone data. So the relative proportions of the categories of rubble, dead coral and coral rock did shift a little bit. And we hypothesised that this shifting of these categories, it's probably as a result of rubble movement, rubble pooling in one area and sort of being moved around from other areas and exposing these different substrates that were underneath it. Now, we didn't see this same pattern in the healthy control site. The pre and post cyclone data showed pretty consistent or stable categories, and we also didn't see it in the restoration side as well. So the hypothesis here is that if the reef is already in a degraded state, that there is some rubble movement when these physical disturbance events happen, but that if the reef is in a healthy state or a restored state, then there's less likely to be rubble movement happening. So the other interesting thing about this site is that it was a multi-stage restoration. So this means that the reef sites were installed over 5 different time points, 6 months apart. And what we saw was that there was some variability in the way each of these sections responded to the disturbance event. So the older, just to summarise the trends, the older and more established sections showed less change in substrate cover, and they showed more accumulation of rubble within the structure. And whereas the newer sections were more likely to mirror what happened in the degraded control site. And the other trend we saw was that deeper sections were a little bit less impact than shallow sections, and that's kind of to be expected. So to summarise the trends that we saw, we found that all sites remained stable under these strong wave conditions, and that there was no negative impact to coral cover at any restoration site. However, we saw that several sites did show accumulation of rubble within that restoration matrix, rubble and other loose fragments as well. And we did see that there was some variability in the way that sites responded to the disturbance event, especially partially due to age and depth as well of the restoration. And all of these results correspond with observations we've seen at other reef sites around the world. So the implications for restoration science and restoration practice, well, we've seen that increased evidence of stability of this particular method, it may shift social licence a little bit on reef restoration. The ongoing use of well-designed interventions, if implemented correctly, could further demonstrate the ability of restoration to resist local impacts caused by global disturbances. And by maintaining the health of reefs at a local scale, by whatever means we have, we can boost the resilience of reef systems to withstand those global impacts. Questions?
Time for one question for Frida. No?